In this video, we'll learn how to calculate z-scores for two different types of scores. First, for scores when the unit of measure indicates larger scores are better, such as in push-ups or shots on goal. In this case, the z-score formula will involve the score in the cell that contains the variable of interest that you use to calculate the mean, the actual mean that you calculated, and the actual standard deviation that you calculated for that distribution. In the second case, we will learn how to calculate z-scores for data where the unit of measure indicates smaller is better, in the case of mile run time or BMI. Here, the first part of the formula is swapped. So you've got the mean minus the score and then divided by the standard deviation again. So let's check this out on Excel. The first thing you're going to need to do is make sure that you have your score set up and that you have a dummy row. Here you're going to create the formula and then apply it to the scores down below from 1 through 25. Note that the mean here that was calculated in the previous video does not include the score of 25. So you put your cursor in the cell where you want to include your formula, equals, parenthesis, you grab your score, you subtract the mean. In this case you want to subtract 36.76, but do not click on the cell there, rather type it. This is really important because it will not work unless you actually type these numbers, and then you have to actually type the standard deviation as well, instead of click on the cell where the standard deviation is located. And then simply click your check mark, the green check mark, and then drag it down. Okay? So you'll see the average z-score then will be calculated, and the average standard deviation for that z-score. I had erased that earlier. Moving on to the next column, for free throw product scores, we'll have the score in the free throw raw score column minus the mean, which in this case is 5.88, and then divided again by the standard deviation. Click the green arrow and then drag the formula down. In this case we can drag the mean z-score formula. And you'll notice that if you've done it correctly, your mean should be 0. In this case, we do not have 0, but it's pretty close. So I've calculated all of the z-scores for the previous performance scores, free throw mechanics, strategy test. Now I'm on the agility sprint test, where I'm going to want to include another row. Here you are inserting, so if you click on the row next to the one in question, you can insert a column and calculate the z-score accordingly. So here we're going to use the formula where lower scores are better. In this case, you want to type in the mean first, so it's 37.52 minus the actual score cell, and then divided by the standard deviation, which in this case is 5.93. So for z-scores, when you average them, the definition of z-scores is that scores have a mean of 0 and a standard deviation of 1. And you can see that in most cases we do have a standard deviation that is very negligible, and then these numbers are not perfectly 0 or 1 because of rounding error.